I welcome you to this lecture that focuses on the reconstruction of past climates. The lecture has two parts. In the first part, we define geological times in terms of eons, eras, periods, and epochs. And I also tell you what we know about past mass extinction events. I give you a little summary. In the second part, we talk about key modes of paleoclimate variability. What do we know about global mean temperatures, maximum or minimum temperatures? So I introduce you to hothouse icehouse cycles, which have a periodicity of around 100 million years. Then I introduce you to ice ages and interglacial warm periods, which have a periodicity of 100,000 years. And I also introduce you to Dansgaard-Oeschger events, which have a periodicity of 1,000 years during ice ages. You can see that we cover different timescales. Okay, so let's get started. We're talking about different points in time and defining different points in time. And this is based on the total age of the Earth. Okay, the Earth is around 4,600 million years old, and on the basis of that, you can define different time spans, okay, or different periods. So the way how this is done is you start with a relatively coarse definition, and this definition is called eons. Okay, we subdivide the entire Earth history into 3 eons. Okay, and we then further subdivide these eons into eras, which are shown here in the second one, eras. Okay, so the sediment records cover the past 540 million years. And because we have more information on the climate conditions, we can further subdivide the last 3 eras into periods, okay, which are shown here, and the latest era we can subdivide it. The last 3 periods that we have into epochs. Okay. All right, and the last epoch, the epoch that we are living in, is called the Holocene, but it's also known as the Anthropocene, as the period in which humans play a big role in determining, modifying the climate, and changing the environmental conditions. Okay. First human ancestors appeared between 5 to 7 million years ago. Okay, so let's have a look at mass extinction events. The known mass extinction events that occurred during the past 540 million years. And a mass extinction event is defined as a loss of more than 75% of all species on a timescale of less than 2 million years. And here you can see the yellow stars show you the 5 mass extinction events, but I also added the red star, which is the current start of another mass extinction event. Let's have a look at the time series. Okay, the time series that's shown in this graph shows you the extinction rate in terms of families per million years. Okay, it's the extinction rates, how many families became extinct per million years. And the x-axis shows you the time, starting from 500 million years ago to present, and also indicated here are the different periods. Okay, so what is meant by families? In order to understand these words, I show you here above my head is this triangle which shows you the taxonomy of living things, the definition, how we define. Okay, and we define, and the finest definition that we use is species, is the species level. That's the finest distinction that we make. And then the higher up, one level up, is called the genus, and then comes the family. Higher up is the order, the class, and so on. And this is shown here for the example of the human. Okay, where the species is the sapiens, the genus is the Homo, the family is shown here, and so the order is the primates, and so on. So what we now know from these mass extinction events is shown here in the details. Yeah, we can distinguish mass extinction events and look at the species, and you can see that there's more than 75% of species became extinct, and also tells you about genera and families becoming extinct in terms of percentage. Okay, and we can define 1, 2, 3, 4, 5 events. Okay, and we can also point into the future a little bit, because that is the start of a new, very likely another mass extinction event ahead. Okay, so let's have a look. What do we know about this? We know a little bit, or there are some suggestions of what has caused these events. Okay, then let's look at these events. And starting from the first one, the Ordovician Silurian extinction, which happened around 440 million years ago. Okay, the presumed cause was a glaciation event followed by a warming event. Okay, so linked to a cooling combination between a cooling and a warming event. Most fauna was marine at that time. There was no life on land at that time. Okay, no fauna on land. Okay, and so what scientists believe is that there was abundant marine plant production, removing CO2, causing global cooling. Okay, link between algae growth in the oceans and CO2, a drop in sea levels reducing habitat, reducing essentially continental shelf areas, shallow water areas. Okay. The adapted creatures were unable to survive the subsequent warming event, and 86% of marine species were lost. This is the second largest known extinction event. And for completeness, I also show you these maps of showing you the composition of the continents, where continent landmass was located, and showing you the oceanic currents and also shallow water regions. Here in this map, you can see the shallow water regions, which are indicated in purple. Okay, and shallow water regions are always important to know, because that's where through the upwelling process, bringing nutrient-rich water into these areas, this is where marine life has formed, where algae growth has occurred. Okay, let's have a look at the second event, the late Devonian extinction that happened 365 million years ago, and again showing you the map of where the continents were located and the circulation. Presumed causes: widespread oceanic anoxia, which is the development of dead zones. And dead zones develop, again, if you have excessive plant production, okay, which creates then bacteria which consume the oxygen. Sea level drop, reducing habitat due to a cooling event. Again, there's a link to it, to a cooling event. Yeah, there's also suggestion of oceanic, volcanoes and possibly a comet impact. So by the late Devonian, the land had been colonized by plants and insects, and the series of events that took place here killed off 75% of species, and the extinction seems to have only affected marine life. Okay, let's go to the next one. The Permian Triassic extinction, which occurred around 752 million years ago. And look at the continents. You know, look at that continent. You essentially just had all the continents spreading from north to south, and the rest of was ocean. You know, that's a fascinating situation. You know, where you have so-called Pangaea sitting over the equator, you know, and Gondwana in the mid latitudes of the southern hemisphere. Presumed cause of this extinction was volcanic activity in Siberia, releasing massive amounts of the greenhouse gas CO2 into the atmosphere. Bacteria thriving on CO2 released methane, another greenhouse gas, you know, leading to global warming and ocean acidification. This was the deadliest extinction events, killing off 85 to 95% of marine invertebrate species and 70% of terrestrial vertebrate genera. Okay? During the recovery, reptiles increased in diversity and number, and the first dinosaurs appeared on Earth. Okay? So let's go to the next one, the Triassic-Jurassic extinction. Presumed cause, CO2 released by volcanic eruptions, or asteroid comet impact triggering release of sulfur gases. In the seas, the entire class of conodonts, which is a type of eels, and 23 to 34% of marine genera disappeared. On land, most archosauromorphs, reptile types, disappeared. Plants, crocodilomorphs, dinosaurs, pterosaurs, and mammals survived this event. But again, linked to a warming event. Yeah? This one, a warming event. Number 5, the Cretaceous Paleogene extinction that occurred 66 million years ago. Presumed causes an asteroid impact in the Yucatan Peninsula in Mexico, ejecting enormous amounts of debris into the atmosphere, triggering dramatic global cooling. Some 76% of all species on the planet went extinct, wiped out all dinosaurs. Sea turtles and crocodilians survived. Okay, in the context, the first human ancestors appeared between 5 million and 7 million years ago. And look at the composition of the continents. It already looked a little bit similar to what we have today. Indeed, the Atlantic Ocean was not fully developed, but we already can clearly see North America, South America. You know, Australia, Antarctica was pretty much connected during that time. Okay, let's talk about the ongoing event, the Holocene, Anthropocene extinction. It's ongoing. Known causes are human impacts, including greenhouse gas emissions, urbanization, pollution, etc. The current extinction rate is 1,000 times greater than normal extinction rates. And that's the end of the first part of this lecture.